Okay, so this is the AC portion of the project. So this consists of a AC current and AC voltage sensing circuit. So the way that the voltage circuit works is we scale down the voltage via a high value divider. It's then AC coupled and biased to 1.65 volts. It is biased to 1.65 volts so that the STM32ADC can safely read it between that 0 and 3.3 voltage value. The voltage is then scaled back up. Essentially, we multiply back through the divider so that we can so that the real world voltage can actually be recorded. The way that the current sensing circuit works, which is right here, it is computed via a current sensing transformer with multiple primary turns to improve sensitivity at low current. The CT secondary current is converted to a voltage across a burden resistor. And then finally, the loop current is actually calculated through several different factors: the voltage across the burden resistor, the number of turns, the CT ratio, and a small calibration constant. The way that we actually compute frequency is through something called a zero crossing detector method using hysteresis to reject noise at the bias point. Power is all converted. Real power is essentially the average of voltage and current. Apparent power is VRMS, IRMS, and then power factor is just real over apparent. So as of right now, we are reading 60 hertz, 12 volts across the load, 0.6 amps through the loop, and real apparent power close to 7.5 for a resistive load, which is exactly what we want. So if John will actually come around here and look at the screen, actually point over here, John, I'm going to plug this in. And then if we go over to the screen here, we can see that it's reading real power, apparent power, voltage, and current, exactly how we want it to do. And now this is all hooked up to the IDE. And I can also explain really quickly the power path for the AC side. So essentially, the 12 volt AC 1 amp wall wart is connected to the perf board, runs through a 5 amp fuse through to the CT with 8 number of primary turns to the 22 ohm 25 watt axial cement power resistor, which then that feeds to AC hot as well as to CT1, which is the secondary of the current transformer. So overall, that is how our AC side works.